Slay the grade, limitless learning, YAS. Gen Z to Gen Alpha and beyond, the basics of computer networking. What is computer networking? Interconnected devices. A computer network is a group of interconnected devices, such as computers, smartphones, and other digital equipment, that can communicate and share resources with each other. Data exchange. Networks allow the exchange of data, files, and information between the connected devices, enabling collaboration, resource sharing, and access to online services. Communication protocols. A computer network is a group of interconnected devices, such as computers, smartphones, and other digital equipment, that can communicate and share resources with each other. Protocols like TCP/IP govern how data is transmitted across these networks, ensuring reliable and efficient communication globally. Networks allow the exchange of data, files, and information between the connected devices, enabling collaboration, resource sharing, and access to online services. The essential components of a network, devices. The core components of a network are the devices that connect to it, such as computers, smartphones, printers, and servers. Communication channels. Data flows through physical or wireless communication channels, like Ethernet cables, Wi-Fi, or cellular networks. Network interface. Each device has a network interface, like an Ethernet port or Wi-Fi adapter, that enables it to connect to the network. Network hardware. Routers, switches, and access points manage the flow of data and connect the various devices and communication channels. Did you know? Networks facilitate not only email and web browsing but also modern technologies like cloud computing and Internet of Things, IoT, where devices communicate and exchange data autonomously. Network topologies. Common configurations. Star topology. The star topology features a central hub that all devices connect to directly. This design allows for easy troubleshooting and isolates network issues to individual nodes. Ring topology. In a ring topology, data travels in a circular path from one device to the next. This configuration offers improved reliability compared to bus topologies but can be more complex to manage. Mesh topology. Mesh networks feature multiple connection paths between devices, providing redundancy and resilience. However, this complexity can make them more challenging to set up and maintain. Fun fact: hybrid network topologies combine elements of different configurations to tailor networks for specific needs, balancing simplicity and efficiency. Ethernet and the role of switches. Ethernet basics. Ethernet is the most widely used local area network, LAN, technology, relying on wired connections to transmit data between devices. Switches for efficiency. Ethernet switches act as traffic directors, efficiently routing data packets between connected devices on a LAN, improving network performance. Switching capabilities. Switches can handle multiple simultaneous data transmissions by establishing dedicated connections between sending and receiving ports. Fact 1. Switches operate at different layers of the OSI model, ensuring efficient data delivery across networks by learning and forwarding data based on MAC addresses. Fact 2. Managed switches offer advanced features like VLANs, virtual LANs, and quality of service, QoS, optimizing network traffic for different applications users. Wireless networking and Wi-Fi standards. Wireless connectivity. Wireless networks allow devices to communicate without physical cables, providing mobility and flexibility. Wi-Fi standards. The Wi-Fi Alliance develops and promotes industry standards, transmission speeds. Newer Wi-Fi standards offer faster data rates, from 54 megabits per second to over 10 gigabits per second, meeting the demands of modern applications. Did you know? The development of Wi-Fi technology began in the late 1990s, and since then, it has become an integral part of everyday life, enabling seamless connectivity in homes, businesses, and public spaces. Fun fact: Wi-Fi standards like 802.11ac, Wi-Fi 5, and 802.11ax, Wi-Fi 6, improve network efficiency and performance, offering higher data rates and better reliability. Network security fundamentals, access control, implementing robust authentication and authorization mechanisms to restrict access to network resources. Did you know? Access control measures include multi-factor authentication, MFA, and role-based access control, RBAC, enhancing security by requiring multiple forms of verification, encryption, utilizing encryption protocols to protect data in transit and safeguard sensitive information. Fact: encryption algorithms like AES, Advanced Encryption Standard, ensure data confidentiality and integrity, crucial for secure communication over networks. Firewall protection, deploying firewalls to monitor and filter network traffic, blocking unauthorized access and potential threats, intrusion detection and prevention, implementing systems to actively monitor for and respond to security breaches and suspicious network activity. Troubleshooting common network issues, network connectivity, check physical connections, verify IP addresses and network settings, test with known good devices to isolate the problem. Performance problems, monitor bandwidth utilization, look for bottlenecks, optimize network configurations, and identify resource-intensive applications. Security breaches, scan for malware, review firewall rules, check for unauthorized access attempts, and ensure all devices have up-to-date security patches. Physical layer issues, like faulty cables or connectors, are often the root cause of connectivity problems in networks, emphasizing the importance of thorough inspection. Fact 1. Bandwidth throttling, where network speeds are deliberately limited by ISPs or network administrators, can affect performance and user experience, prompting the need for optimization. Fact 2. Zero-day vulnerabilities, unknown to software vendors, pose significant risks to network security until patches are developed. Emerging network technologies trends, 5G and beyond. The rollout of 5G networks is enabling faster, more reliable wireless connectivity with lower latency. Did you know? 5G technology can achieve speeds up to 100 times faster than 4G, revolutionizing industries like healthcare, transportation, and entertainment through enhanced connectivity and responsiveness. This is paving the way for the widespread adoption of IoT devices and smart city applications, creating a more connected, efficient urban environment. Software-defined networking, SDN technology allows for more flexible, programmable network management by decoupling the control and data planes. Edge computing, with the growth of IoT, edge computing brings data processing and intelligence closer to the source of data. Future trends in networking, adoption of 5G and beyond. The widespread implementation of 5G is revolutionizing connectivity with ultra-low latency and higher data speeds. Did you know? 5G technology enables data rates up to 10 gigabits per second, significantly enhancing capabilities for autonomous systems, smart cities, and augmented reality applications. Future networks like 6G aim to push these boundaries even further, exploring technologies such as terahertz frequencies and massive MIMO, multiple input, multiple output, for unprecedented speeds and connectivity. AI-driven network management, artificial intelligence is transforming how networks are monitored and optimized. Rise of edge computing. Computing brings data processing closer to devices, reducing latency, improving efficiency. Do like, share, comment, and subscribe. Fact: this trend is crucial for real-time applications like IoT devices, autonomous vehicles, and remote healthcare solutions, where immediate data processing and response times are critical.